All right, here we go. Video 3. I think we have 4 pages of examples to go. Yeah. 1, 2. Yep. So let's get through this. You have the identities here, right? Guys, if you're taking AP Calc next year, got to memorize these, right? You won't be given them. They won't be given to you. If you're taking HL, I believe analysis or apps, they will be given to you. And same thing for SL. All right, so you know, it's tough because we're trying to prepare you guys for both those sequences, but that's why we're showing you how to prove them. If you forget, you can kind of go through it. Okay, so first example here. This guy. Use a difference identity to find the exact value of sine 15. Okay, so this means I want to create a difference, right? That gives me 15. So I'm going to use 45 and 30, right? So the sine of 15 degrees, well, that's really equal to the sine of 45 minus 30 degrees. And now I can use this identity right here and go through it, right? So this is equal to sine 45 cosine 30 minus cos 45 sine 30. Okay, let me just double check that everything's right. 45 is first, so I should have sine 45 cosine 45, yeah. 30 is second, so I should have cosine 30 sine 30, yeah. This is a minus, this is a minus, this is a minus, yeah. Okay, now we can compute. Sine 45, that's root 2 over 2. Cosine 30, that's root 3 over 2. Cosine 45, root 2 over 2. And sine 30 is a half. Just make sure I did all that right. Yeah. So that means that this is going to turn into root 6 minus root 2 over 4. Wow. So weird number, but kind of cool. So we can compute now the exact value of sine 15. It's this weird number without a calculator. Next one, same idea but with radians. Okay, 5 pi over 12. So it doesn't say to use a difference or a sum. We can use either. So I'm thinking, well, how can I get 5? And I know basically I have multiples of pi over 6, pi over 4, and pi over 3, which is really the same as 2 pi over 12, 3 pi over 12, and I guess I could stop there because that gives it, or 4 pi over 12. All right? So I'm going to use a sum with these two. So the secant of 5 pi over 12, well, that's the same thing as 1 over the cosine of 5 pi over 12, which is the same thing as 1 over the cosine of 2 pi over 12 plus 3 pi over 12. So I'm going to write it this way just to make it a little bit easier on myself. Pi over 6 plus pi over 4. So this is cosine pi over 6 plus pi over 4, which is equal to 1 over, and now we can use our cosine identity. We need cosine of a sum. So it's going to be cos pi over 6 cos pi over 4 minus sine pi over 6 sine pi over 4. Okay. Now again, got to know that unit circle so I can compute this. So this is going to equal, I'm going to go up here. This is going to equal 1 over cos pi over 6. That's root 3 over 2. Cos pi over 4. That's root 2 over 2. Sine pi over 6, that is a half. And sine pi over 4, that's root 2 over 2. So this is equal to, and I'm not going to bother simplifying because that's not really, I mean, that's not what we're looking at here. This is 1 over root 6 over 4 minus root 2 over 4. So messy answer again, but the secant of pi over 12 is that. Okay, some simplifying. So we need to recognize what identity we're using here. So I've got sine and cosine, so right away I'm thinking this is a sine identity. I've got a minus, so it's a minus sine identity, right? So this is really just the sine of 100 degrees minus 10 degrees, which is the sine of 90, which is 1. Okay? If you remember sine of a difference, sine of the first, cosine of the second, minus cosine of the first, sine of the second. And that, I believe, is what we have here. This one, well, this is cosine, so it's a cosine identity. If this is a minus, it means it's a plus inside. So this is, let's think of it this way. This is like cos A. This is cos B. This is sine A, sine B. So this is really the same thing as the cosine of A plus B, which is the cosine of pi over 4 minus theta plus pi over 4 plus theta, which is the cosine of, the thetas cancel, pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2, and then hopefully we remember that cosine of pi over 2 is 0. Okay, yeah, these are very popular IB questions, right? So we're given two things. Cosine A is 3/5, cosine B is 5/13. This is telling us the quadrant that the angle's in. So alpha, and I keep saying A, it should be alpha. Alpha's in quadrant 1, beta's in quadrant 4. Find the exact value of cos alpha plus beta. So what I like to do is draw it out first and then use the identity to compute. So I'm going to write the identity first. So this is equal to cos alpha, cos beta minus sine alpha, sine beta. Okay, now a couple of things we can fill in right away. Cosine alpha, we know it's 3/5. We don't know the sine, but we know the cosine. And cosine beta, we know is 5/13, but we still need these two. And in order to find those, we're going to have to draw them out. So alpha is in quadrant 1. So I'm going to draw a triangle here. This represents alpha. And the cosine of alpha is 3/5, so adjacent over hypotenuse. That means this is 4 from Pythagorean theorem, and we know it's a positive 4 because of this, right? Negative 4 would also work. It would still make these two sides 3 and 5, but that wouldn't satisfy this condition. All right. So now I know the sine alpha is 4/5. And I'm going to do the same thing with beta. Beta is in between 3 pi over 2 and 2 pi, so it's in quadrant 4. All right, so I'll draw that out. There's a triangle in quadrant 4. Remember, guys, when we're drawing these triangles, your central angle always should connect to the x-axis. Always, 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 okay? I saw some people before trying to make triangles where it was connecting the y-axis. No, the angle here always, always, always has to connect to the x-axis. All right, so what do we know about beta? The cosine is 5/13, so that means this is 5 This is 13. This is going to be a negative number. This is going to be a negative number, and it's going to be, what is that? 13 squared. Is that 169? It's a little bit embarrassing. I can't remember. 9, 3. Yeah. So okay, 169. So 169 minus 25 is 144. The square root of that is 12, and that should be negative. So the sign of beta is going to be opposite over hypotenuse, negative 12 over 13. So the whole answer is going to be 15 plus 48 over 5 times 13. What is that? 65, right? 65. Yeah, 65. So that's 63 over 65. And that's, yeah, well, I don't know how to highlight that. That is what cosine of alpha minus beta is. It's this. All right, 2 more pages. Prove this identity. Okay. So we want to prove that sine alpha over sine beta plus cosine alpha over cosine beta is equal to this. Yikes. Well, with a proof, we only can work with one side, and I like to go from more complicated to more simple, right? And I'm saying this is more complicated because this is 2 terms. So I've got 2 terms, and I want to merge them into one. We better have a common denominator, right? So I'm going to start with the left side and say I want a common denominator. So this left side, I'm going to write the left-hand side, the LHS is equal to, so the common denominator of this, I need both of these. So in this first term, I'm going to multiply by cosine beta, top and bottom. In the second term, I'm going to multiply by sine beta, top and bottom. So that means that we get cosine beta sine alpha plus cosine alpha sine beta all over that common denominator, which is cosine beta sine beta, equals 2 sine. You know what? Actually, I'm just not even going to write that. So, okay. So let's look here now. So this is, oh, whoops. I wanted to mouse that, not. Okay, guess I have no shot. So, gotta rewrite this, guys. That's the kind of day it's been. That's all right. So this is cos beta sine alpha plus cos alpha sine beta all over cos beta sine beta. Okay, now what I want to do is take the mouse and I would say, all right, sine alpha plus beta, well, we just know what that is. That's sine alpha sine beta, right? Sorry, sine alpha cosine beta, which is this, plus cosine alpha sine beta, which is this. Okay, the only difference is there's 2 here. So if I want to make my top match this, I need to multiply by 2, which means I need to multiply the top and the bottom by 2. And I'm going to also just change it so it's in a better form. Sine alpha cosine beta plus cosine alpha sine beta. Now, again, if I multiply the top by 2, I have to multiply the denominator by 2. Sorry, I don't know where this came from. It's going to bother me a little bit. That should be gone. Okay, 2 sine beta, cosine beta, So you can tell this problem's hard. It's not just the trig, it's my iPad's giving me trouble. So, all right, so now what do? We got this and this by creating common denominator and adding the top. We realized, okay, this matches that. But if this has a 2 in front of it, I need to multiply this top and bottom by 2. Okay, so now this check equals that. And I think you remember us seeing this double angle, sine 2 beta. If not, I'll write it out. Well, this is an easy one to remember. This is actually 2 sine beta, cosine beta, which is exactly what we have here. So that's it. And I guess we should go one more step. We should say a little bit more formally, this is equal to 2 sine alpha plus beta over sine 2 beta. And then done. QED. Such it was demonstrated. Thus it was demonstrated in Latin. Okay, last page, guys. Last page. So, yeah, pretty intense day, but it's okay. You guys are capable of handling it. Here we've got a function. We want to simplify the function. Okay, so I've got a sine sum, and I've got a sine difference. And we have formulas for those. So, wow, we're going to expand both these all out and hopefully get some cancellation. So this is going to equal sine pi over 4 cos x plus cos pi over 4 sine x. So this is that. Then we've got minus, I've got to put parentheses here, sine of a difference. So that's going to be sine pi over 4 cos x minus cos x, not cos x, cos pi over 4 sine x. Okay, so when we distribute this negative, that goes to this, and then this becomes plus. So look at this, I've got cos pi over 4 sine x twice, and I've got sine pi over 4 cosine x twice. So these are going to cancel, right? Let's get a red here to cancel. So this and this go away, and we're left with 2 cos pi over 4 sine x, which is really 2 times root 2 over 2 times sine x, which is really root 2 sine x. So if you guys want, if we've done this right, and I think it's right, if you put this into Desmos and you put this into Desmos, they're going to be the exact same thing. Okay? Hey, I didn't read. Verify the solutions in B graphically. Okay. So I thought they were going to say verify the solution in A graphically. But we have to do B, and then we can use Desmos or some other kind of tech to verify graphically. This, by the way, you don't have to draw manually, right? You can use any kind of tech. Desmos, your calculator, Wolfram to verify them. Use the result in A to solve the equation f of x equals -1 on this interval. Okay, so basically what it means is we can start by setting this nasty equation equal to -1, but we can realize this is really just this. So this feels like an old IB question. We could say that root 2 sine x is equal to -1, which means sine x is -1 over root 2, which is really the same thing as root 2 over 2. And now I'm thinking pi over 4 intervals, right? So if I want sine x to be negative root 2 over 2, I've got to be in quadrant 3, quadrant 4. This is going to be 5 pi over 4. This is going to be 7 pi over 4, and that's it because we have this particular solution. So x is equal to 5 pi over 4 or 7 pi over 4. That's a weird looking pi there. I don't know what I was thinking there. 7 pi over 4. All right. Well, that's a good last answer. To verify the solutions graphically, this part I'm going to let you guys just do that on your own. I know you can check it, okay? And I know you'll probably let me know if something's wrong here. I think I did most of it right. Hope so, but nobody's perfect, so you guys find an error, especially if you're my students, let me know, all right? Homework is out of the packet, page 4, so we will post those in classroom. You guys have a good day, and we'll see you soon, hopefully.